Hello, my name is Angel Torres, and today I'm going to be telling you about liquefied natural gas, or LNG. Now, I'm mainly going to be focusing on the chemistry aspects of it. LNG is mainly composed of methane, which is CH4, and ethane, which is C2H6. The molecular weight of methane is 16.04 grams per mole. The molecular weight of ethane is 30 grams per mole. Together, these add up to 46.11 grams per mole. The physical properties of LNG is that it is colorless, odorless, unless of a mercaptan is added. Now, what is a mercaptan, you may ask? The best example I can give of a mercaptan is propane. Like when you fire up a propane grill, to be exact, sometimes a distinctive odor will come up to your nose. Now, you may be thinking you are smelling propane. But you are not smelling propane. You're smelling the mercaptan that's been added for your safety. It is stable stored property, it is non-toxic, and non-corrosive. The chemical properties of LNG is that it has a melting point of 455.372 Kelvin. It has a freezing point of 110.928 Kelvin and a flammability flash point of 494.261 Kelvin. Now, why Kelvin? This is because Kelvin is widely accepted in the scientific community, as Fahrenheit is mainly used in the US, and some countries do not use the metric system of Celsius. These are the molecules of methane and ethane. They are both tetrahedral. As we can see, we have the two Lewis structures, the ball and stick figures, and the 3D models of methane and ethane. Now, why LNG? Why go from a gaseous state to a liquefied state? For one, it is easier for transport. Example, shipping especially. Two, there is less pipelines involved. And three, there is peak demand for LNG. So therefore, we really want a very stable gas to be able to be shipped. The second thing is storage for confinement and national security. Now, the best example I can give for confinement and national security is if you have a bucket of water. If it evaporates, the molecules go up and they turn into steam. You don't know where that steam went. You don't know where that gaseous state is. However, in its liquefied state, you know exactly where that bucket of water is. Finally, it's for the environment. Less pipelines means less manpower, less cost, less infrastructure, and we don't have to tear up as many things in the environment. We don't have to displace as much biodiversity in the environment. Now, how is LNG made? First, it is extracted through drilling and hydraulic fracturing, or fracking. Now, what we have here is a simple pretreatment. We have the removal of mercury, which in the example we give is 1Hg, the removal of hydrogen sulfide, 1H2S, the removal of carbon dioxide, 1CO2, and the removal of water, 1H2O. Finally, it is frozen to 110 degrees Kelvin to get that pure methane and ethane. We do have a chemical formula on the right here. We have 1Hg plus 1H2S plus 1CO2 plus 1H2O all divided by 1. And these are the reactants here on the left right here. They are going to the products which are on the right, which is 1CH4, 1C2, H6, also divided by 1. Whenever we divide all this by 1, the reactants cancel, and we are left with pure methane and ethane. Now, you may ask, is it really this simple? Yes and no. The example of our pretreatment here is very simple. Now, whenever you extract natural gas, it really depends on the conditions underground or under the seabed where you're drilling or where you're fracking. This also depends on the region where you're doing this. So this is why it is not that simple either. But we also chose the coefficient of 1 because we want to keep this as simple as possible and as low as possible. Now, uses for LNG. The main use for LNG is energy in the form of heating and electricity. In fact, a third of U.S. households depend on LNG for their electricity use. We also have geopolitics involved with LNG. Now, at the time of this recording, there is a current crisis as there is a war between Ukraine and Russia. The majority of Europe depends on Russia for their LNG, which means they depend on Russia for the majority of their electricity. Now, there are some environmental issues surrounding LNG. As we know, LNG stands for liquefied natural gas. It is cleaner burning than coal, and you don't have to worry about the nuclear fallout as you do with nuclear power. However, it is explosive, and we do burn excess natural gas in what we call flaring, which releases the greenhouse gas of methane. Finally, there's drilling and fracking we had to worry about because of the water contamination. If you would like to learn more about LNG, here are some great sources to start off with. Thank you.